Hello. In this video, we're going to be graphing the function f of x equals 1 over x. And this type of function, because it is a fraction, is called a rational function. Remember, rational numbers are numbers that are allowed to be written as fractions, something over something else. And that's what we have here. Now, before we get into graphing it, I want to talk about the function 1 over x. Now, what sort of things are in the domain of this function? Meaning, what can I plug in for x? And honestly, I can do fractions of literally anything I want. A fraction of 1 over 1, 1 over 2, 1 over 3, except I cannot do 1 over 0, because that is undefined. Nice scribble word undefined there. So my domain are all of my x's such that we don't have 0. And what about the range? Well, if I have 1 over something, if you give me any number and put it down there, 1/5, 1/100th, 1/300th, 1/1,000,000th, I have numbers that are very, very, very super small, but I can never have a number that is going to be equal to 0. So once again, this can't be 0 either. So our range is the same thing. All of our possible y values where y isn't equal to 0. So let's go ahead and graph this and see what it looks like. Now I'm going to put in an xy chart here and start picking some numbers. What I'm going to do is I'm going to start by picking numbers like 1, 2, 3, 4. And if I put those in, 1 over 1 gets me 1, 1 over 2 is just a half, 1 over 3 is a third, 1 over 4 is a fourth. So I have the points 1, 1, 2, 1/2, 3, 1/3, 4, 1/4. We kind of talked about this, how I'm getting closer and closer and closer to 0, but I'm never actually going to touch 0. And so like the furthest out I can go is 7 on my coordinate plane, and so I get 1/7, and when I'm out there, I'm sitting very, very close to 0, but I'm not actually touching it. Well, what's the behavior of this function as we get closer to the y-axis? Well, what if I tried something like a half, or a third, or a fourth, and I plug those numbers in? So if I plug that in, I get 1 over 1/2. Well, how do we divide fractions? 1 divided by 1/2? Well, if you remember, that's the same as multiplying by the reciprocal. So 1 over 1/2 is 2. Or if you think, if I have a whole amount, so that's one whole amount, and I divide it into groups of 1/2, how many groups do I have? And that would be 2. So if I do 1 over 1/3, same basic concept. I have a whole, and I'm going to divide it into groups of 1/3. How many groups do I have? It's 3. Or, if I consider 1 divided by 1/3, it's the same as 1 times 3 over 1, or just the number 3. So hopefully you can guess the next one. 1 over 1/4 ends up being 4. So 1/2 gets me a result of 2. 1/3 gets me 3. 1/4 gets me 4. And once again, we talked about how I can never have 0 get plugged in, and I'm never actually going to get to the y-axis because I can't put a 0 in for x. But notice that I'm getting super, super close to the y-axis. So the function looks like this. We don't touch the x-axis. There we go. The function looks like this when we input positive numbers. Now, what if I input negative numbers instead? -1, -2, -3, -4, -7, -1/2, -1/3, -1/4. What if I did that? Well, I'd have 1 over -1, and I'd get -1. I'd have 1 over -2, and I'd get -1/2. I'd have 1 over -3. And so all of these turn into negatives. All my results turn into negatives. And so I have -1, -1, -2, -1/2, -3, -1/3, -4, -1/4, -7, -1/7. And it's kind of mirroring what's happening in the first quadrant, but it's in the third quadrant instead. And so, once again, we get close but never touch the x-axis. And we get close but we never touch the y-axis either on the other side. And so that's what this rational function will look like. And what we have is something called asymptotes. This x-axis right here is a line that our function gets super close to, but it never touches. And in math, that's called an asymptote. And here, my y-axis is also, because we get closer and closer to it but never touch, also called an asymptote. We'll talk more about rational functions in class tomorrow, but for now, we are done.